everyone. I'm Daniela and I am a postdoctoral researcher at the University of Study in Chieti Pescara in Italy. And I will present my research paper entitled Economic Agent Metal Brain, a Biological Economic Complex Agent. As you can see from this slide, you can see a sort of summing up of my work, and we can start from the big question of my talk, and it will be how it's possible to implement economic agent choice behavior model within the theoretical framework of active Bayesian inference. Starting from the economic basics, we have that the last decade, the agent-based model presented behavioral changes. In particular, agent-based model could produce behavioral complexity without a complex brain, and some models assume that task of developing a brain like functional model. Consequently, we have the implementation more and more much realistic and informative models. In particular, the neuron computational model called the metal brain model, and the modeling a specific cognitive process, in particular the acquisition of the external knowledge by economic agent. Instead, the mathematical basis is based on the active inference principle, where economic agent has a generative model of the world, which is a joint distribution of observation epsilon and subject-specific parameter omega, or in other words, the sensory input. In more depth, this distribution is based on a likelihood function PA over omega and a prior distribution over parameter probability of omega. These have the consequence that the agent influence an optimal policy by minimizing the relative entropy, or the so-called Kullback-Leibel divergence between the belief and the distribution of the likely outcome. But all of this derive from the two simple questions of how coupled dynamical systems behave when they organize themselves. Instead, this is possible since economicists places an upper bound on the expression of sensor states while using this sensation to infer external state of the world, making the free energy bound a better exact estimation of the action that economic agent try to minimize. This derives from the fact that economic system could be considered ergodic in the sense that the average of any measure of the states converge over a sufficient period of time. An economic system is equipped with a Markov blanket, and the economic agent exhibits an active framework. This is possible since given the existence of the states partition implied by the Markov blanket, it reveals the hidden causes of the sensory states by minimizing free energy bound on the log Bayesian evidence. But it is possible since economic agent could be considered a complex system because of the reformulation of the second law of thermodynamics, which offers the possibility to formulate the economic evolution in terms of the development of the structural complexity, seen as the transformation of the available environment into a gradient, the region gradients. So how is the setting of the free energy principle? This principle assumes that a random dynamical system can be considered in terms of Langevin stochastic differential equation, as you can see from the first equation, and consequently it assumes that the system will reach a non-equilibrium steady state as follows. This is the second equation. And what happened in this context to the agent belief about policies? According to this framework, economic agents select policies with a low expected free energy according to the following equation, where the first term is the prior preferences that are uniform across all outcomes, and the second term is the epistemic barrier or silence. But how the economic agent face uncertainty? They could infer the persistence of its environment in terms of likelihood state functions by means of the Bayesian inference. Since, as we have seen, agent possess a generative model that incorporated the uncertainty itself. From a mathematical point of view, this statement could be formalized with a computational basis of both uncertainty in the brain and the information gathering behavior of the agent, as you can see, where the probability OS is the agent generative model, QS is the factorization of the economic agent belief. This approach produces explicit belief about uncertainty in discrete state space. But the empirical part of my work is this economic agent metabrain. In particular, this generative model is decomposed into a likelihood, so the probability of sensory data, and the a priori probability of these causes. Then the perception becomes the process of inverting the likelihood model to access the probability of the causes given the sensory data. So the real economic agent metabrain is this one, this equation, where it is assumed that P or S over O is not zero, and QS is also non-zero, and we have this implementation that is the metabrain. So the implication of the specific economic process, this implies that the specific economic process could be summarized as follows, where the first term is to look for the information it can provide for a prediction on what the best policy will be, and subsequently, based on the information available within the context, the next steps are motivated by sub-strategies that attempt to align the desired events with the real ones. Throughout this measurement made by the agent, any future approximation will be aimed at solving the problem of uncertainty through the progressive revelation of the end state of the world. Thanks for listening, and you can contact me at daniela.cialfi@unich.it. Bye.